I found that my cell phone's camera had more than enough resolution for images to be streamed on the web, and I found the Android program Camera FV5 with functions for time-lapse photography. So I poured mud into a graduated cylinder, and as it settled, my cell phone camera snapped images and stored them every 8 seconds. So 2.5 hours later, over 1,000 images are stored on my camera's memory card. I now need to import them into a program that will assemble all these images into a video file for web streaming. Some years ago, I had purchased a copy of QuickTime Pro version 7 for about $29. The Pro version had all the necessary options for the time-lapse project. I just needed to learn which settings would produce results. Instead of opening a single file by name, QuickTime Pro opens an image sequence. The program has the smarts that recognize the image sequence. You point to one file, the name of which includes a number in the sequence. Pro then finds the file with the lowest and highest file name numbers and all those in between. It then imports all these files for processing. The first numbered file in the sequence is displayed. I want my video to be produced for streaming over the web, but for manually choosing some options, I click into the plain export command, not the export for the web choice. The exported file will be wrapped in an MP4 container with additional options available here. Here is where the resolution is set to 1280 by 720, optimized for high-definition web streaming, and the download menu specifies the streaming option. The folder where the movie file is to be stored is selected. Processing proceeds and the movie file is created. So after all that work, how does a time-lapse movie look? Let's watch. I think there are lots of interesting questions that can be addressed by the time-lapse movie. You can't see the individual particles of mud, so how do you know they're being deposited on the bottom of the cylinder? Why does the interface between the sediment and the water column appear to become more sharp with time? Can you think of a way to quantify the sediment that's already been deposited by some sort of optical method without touching the cylinder? Do you think the level of water in the cylinder should change as sediment is deposited on the bottom? There are numerous other opportunities for time-lapse studies in geology. The work to make another one will be a lot less the second time around. Let's compile ideas to exploit the dimension of time in time-lapse photography so that we can further explore fundamental phenomena that occur all around us. I'd even entertain the role of time-lapse volunteer. From time to time, Scott Brandy here at UAB, signing off.